Hyrule is a land of magic, monsters, and the scariest lightning storms you've ever seen. If you've begun to take off your metal shield, congratulations, your body is initiating an unscheduled full system reboot. Right behind me is one of the amazing vistas found throughout the Legend of Zelda series. It's beautiful, stunning even, so you might think, wow, what a great place to climb and get some footage for my YouTube channel. But what happens as soon as you start trying to climb this? Rain. Trying to hit record? Rain. One notch of your stamina bar left at the top of the cliff? Straight to rain. Anytime you try to do anything in this game, it feels like it starts to rain. But here's the thing. In real life, rainfall depends on the local environment. Rain on Earth can range from 0 to almost 39 feet per year. That's just under 12 meters for all you fine folks across the pond. But what about in Hyrule? Is our impression right? Is it really raining constantly in Hyrule? Does it rain more in the tropical forests of Faron and less in Hyrule Field? Or are the people of Hyrule just planning their own Noah's Ark quest? Better get to building. Well, my wife and I did months of research into hydrology, rainfall, and why that one guy climbing Mount Lanayru probably has frostbite. Yikes. All to figure out how often it actually rains in Hyrule. But to know that for sure, we had to go on a rain quest and document the rain in every single region of Hyrule. In each of Hyrule's 8 regions, we tracked down every rainstorm, snowstorm, and every terrifying lightning strike that the sky decided to throw at us. But hold on, you might be wondering, how exactly do you even study rain? Well, in the real world, scientists use a mix of physical devices and satellite imagery to measure precipitation intensity, accumulation, and distribution, all to tell how hard is raining, for how long is it raining, and who might need to mow their lawn again. But what about before we had all the remote sensors and satellites doing the heavy lifting here? Well, meteorologists had to physically walk over to each area and check rain gauge levels, which meant they couldn't check every rain gauge every time it rains. So instead, they used a randomized approach. This method is called cluster sampling, and it's a key staple in modern science. The gauges here are grouped by area, and a few from each group get selected at random. The key word here is random, because you can't just stroll over to the gauges that look full and ignore the ones that have a light sprinkle. That's how you end up publishing a paper called Apocalypse Confirmed, when in reality it was just Steve's backyard. Randomization removes researcher bias and makes sampling fair. So what about in Hyrule? Can you even measure the rain in this way? Is Tingle standing out there with a rain gauge in a lightning storm? Wow! Well, not exactly. We spent 30 in-game days in each of Hyrule's 8 regions. And that's a total of 8 months measuring the rain in Hyrule. And when I say measuring, I don't mean, wow, it's raining again. I mean logging it, timing it, and categorizing it, like meteorologists, but a little bit more portable. We divided Hyrule into 8 clusters for sampling based on its regions. And every 2 in-game days, we randomly selected a new location to observe. That means every 48 hours, we packed up, relocated, and started watching the sky again. And yes, that is as boring as it sounds. Link doesn't even get a tent break. He just stands there, wet, reflecting on his life choices.
Did I leave the oven on?
We visited each region a total of 15 times and stayed for 2 days. That's a total of 30 days in each of our study clusters. This randomized method ensured that the observations for each region were spread out across 8 months. We separated rainfall into 3 categories: drizzles, heavy rain, and lightning storms. We then used intensity and duration to calculate accumulation across all of Hyrule. And based on these calculations, we classified each region as orange, It gets less than 10 inches per year. It's probably a desert. I hope you brought your water bottle. Green, 10 to 60 inches per year. This is a sweet, sweet spot. Go sit on your front porch and watch the rain come down. Light blue, 60 to 100 inches per year. It rains a lot here. I hope you have some really nice rain boots. Dark blue, 100 to 400 inches per year. It's starting to get alarming. It might be the rainforest, or it could be a flash flood. Or purple. It rains more than 400 inches per year. That is more than anywhere on Earth. And this is apocalyptic levels of danger. I hope you like boating. By the end of our journey, we will have a fantastic visual map of just how much or how little it actually rains in Hyrule. And let me tell you, what we found was shocking. Let's dive right in. We start our journey in Faron, a beautiful green region full of stunning lush forests and sweeping grasslands. And this is where we encountered our first problem. See, in each of Hyrule's 8 regions, there are a ton of different biomes, and that means there might be different levels of rain across a single region. A biome is a distinct geographical area of Earth, classified by its unique climate, soil, plants, and animals. In other words, there should be different amounts of rain in the forest versus the grassland. So before we could even start compiling our data, we had to figure out what biomes existed in Hyrule. We ended up grouping all the areas into 8 different biomes, all based on the plants and animals that we found. And here's how we broke it down. Boreal forest. Think pine trees and snow. My friends up north, Canadians, you know all about this. Montane biome. This looks a lot like a boreal forest, but it sits on top of the tallest mountains on Earth. Think, the Rockies, desert below, but pine trees up top. And then we have temperate forest, forests where the leaves fall in autumn. Go ahead and grab your pumpkin spice latte. And then we have temperate grassland. These are the same temperatures as temperate forest, just a lot more grass instead of trees. And then we have temperate wetland. Same story here. Warm summers, cold winters, but this time the ground is really wet. And we have tropical rainforests, found near the equator, hot and sunny year-round with an absolute insane amount of rain. And then we have deserts, dry areas usually hot but with almost no rain. Think Death Valley. And then we have volcanic desert. Almost no vegetation, but for very different reasons. Volcanoes aren't always nice places to live. Let's start with the tropical rainforest. Down at the southern edge of the continent sits the wet forest of Faron. It's packed with massive trees, thick moss, hanging vines, and enough wildlife to make you feel like you're accidentally walking into a David Attenborough nature documentary. This here is the bushy-tailed squirrel. With its magnificent plumed tail, almost as long as its body, it balances effortlessly among the branches. Every leap is a calculation, every landing precise. Wait. Look, that's the wrong video. Wrong video. Everything here is green and damp and looks like it could either heal you or poison you. Naturally, we expected this region to get a lot of rain. In real life, rainforests get year-round rainfall. It can rain up to 250 days a year with accumulation exceeding 100 inches per year. These forests are near the equator, which means they don't experience summer and winter the same way we do. Instead, temperatures stay warm year-round. But many tropical regions do experience something called a monsoon season. A monsoon season is a period of several months marked by significantly heavier rainfall. Surf's up, my dude. But the rest of the year, things calm down a bit. Still wet, just not miserably wet. So going into Faron, we had a clear hypothesis. if Hyrule's climate follows real-world tropical patterns, Faron should be one of the wettest regions on the map. And it's certainly wet. It rained every single day we were in the rainforest of Faron. We spent days recording the rain around Florian Bridge, the Damal Forest, and the Spring of Courage. And on average, it rained 8.7 hours per day, which would be approximately 4 inches of rain. And, well, that's not bad. 4 inches, right? Well, when you multiply that by 365 days, that's 1,512 inches per year, which is 126 feet of rain every year. Whoa. And that's a conservative estimate too. What I mean by that is we took all our estimates from the low end of the possible rain. In a heavy rain on Earth, it can rain between 0.3 to 1 inch per hour. So we estimated 0.3 inches of rain. And in big storms like a terrifying massive lightning storm, it can rain 1 to 4 inches per hour. So we estimated 1 inch per hour during big storms. And even being conservative, we found 126 feet per year? Well, we did say that the rainforest would have the most rain. But we're definitely going to have to give this a purple rating. Yikes. Okay, so what about the rest of Faron? Maybe it rains a little bit less in the other areas. Well, the rest of Faron is a temperate grassland. Temperate means that it should be a little cooler here. And the grassland, well, it means it's got grass. But specifically, grasslands are full of grass because it usually rains a lot less here. These regions don't have enough rain to support the large, awesome trees that a rainforest would have. So, grass dominates the landscape instead. In general, temperate grasslands get anywhere between 10 to 30 inches of rain per year. So we looked across Hyrule to see how far the grassland biomes extend. After some on-the-ground research, we decided to include parts of Faron, Necluda, basically all of Central Hyrule, and a few places in Lanayru and Akla. Link does love a good run through grass fields after all. And what did we find? Does it rain less in Hyrule Field than the rainforest? Not really. It once again rained every single day. In fact, it rained an average of 13 hours a day, which means that it is literally raining more than 50% of the time. Oh my Yoshi! What the heck, Nintendo? There were a lot fewer big storms here though. But even still, the accumulation came out to a whopping 1,623 inches of rain per year. That's over 135 feet of rain in a year. More than the rainforest to the south. I am feeling so justified in making this video right now. These numbers are mind-blowing when you consider the wettest place on Earth gets 38 feet of rain per year. So not only is the grassland in Hyrule not drier than the tropical rainforest, it's somehow even wetter. And it's no surprise, it's gonna get a purple rating from us. Gerudo Desert. I normally like to throw some cool music montage for Gerudo, like in our Is Hyrule's Water Safe to Drink or Is Hyrule's Air Safe to Breathe videos. But this time, I think I'll spare you. This time. And boy, weren't we glad for a change of scenery from the crazy rainfall of the first two biomes. Because after months of slipping down cliffs, we needed proof that Hyrule's rain actually has an off switch. Deserts in the real world are the driest places on Earth, and they are defined by receiving less than 10 inches of rain per year. And some deserts even get significantly less than that. And visually, Gerudo Desert absolutely nails that aesthetic. It's sandy, sunny, and vegetation is Well, minimal. But there is water here and a few plants scattered about. So moisture here must be more than just a rumor. But there's already something very suspicious going on. Because in the real world, we wouldn't actually expect a desert to be here. What? And that's where things get interesting. See, locations of deserts and rainforests aren't random. God didn't just wake up one day and say, desert here. Oh, rainforest over here. They're actually controlled by global air circulation, specifically the massive atmospheric loops that surround the planet to the north and south of the equator. Here's how that works. Right at the equator, where tropical rainforests live, the sun heats the surface a lot. The air gets hot, rises, and as it rises, it pulls moisture up with it. Warm air can actually hold a lot of water vapor. But as that air climbs higher and higher into the atmosphere, it cools rapidly. And when air cools, it can't hold as much moisture anymore. So the water condenses into clouds. And then, before the air mass can drift very far north or south, all of that water falls back down as rain. A lot of rain, which is why the equatorial regions are wet, humid, and permanently bad for maintaining your hairstyle. Ladies, avoid Faron if you just finished up at the hair salon. Wait, is that why the Gerudo have fantastic hair? Okay, but here's the important part. Once the air has dumped all of its moisture, it keeps moving. And by the time it reaches roughly 20 to 30 degrees north or south of the equator, it's dry, like a shriveled up re-dead dry. That dry air sinks back toward the surface, creating high pressure zones with very little precipitation. And that is where deserts form. The air then flows back towards the equator near the surface, heats up and rises once again, and the whole cycle repeats. This awesome global pattern is called a Hadley cell. And it's one of the fundamental drivers of the Earth's entire climate system. And it's one of the reasons why most of the world's major deserts all sit between 15 and 30 degrees north and south of the equator. Knowing all of that, we have a big problem. Because in Hyrule, well, Faron is clearly a tropical rainforest. And Gerudo is clearly a desert. And they're basically neighbors. Which, in real-world climate terms, is like putting the Amazon next to the Sahara and pretending that's normal. Faron and Gerudo should not be sharing a property line. One of them is violating some serious atmospheric laws here. Okay, but how much rain did we observe and record in Gerudo? Well, it turns out that the deserts of the Gerudo receive absolutely zero rain. Not very little, not rare seasonal drizzle, zero, nothing, nada. There wasn't even a single guy with a zone ice sprinkler system up on Gerudo Highlands throwing water around here. It was dry. And it gets even better, because in Tears of the Kingdom, it actually gives you a weather forecast in the corner of the screen. And in Gerudo, it's just suns. All suns. No clouds, no question marks, just suns for days. Which means for 8 in-game months, the sky over the Gerudo Desert never changes. Just like my opinion of the CDI Zelda games.
That is one big pile of shit.
Which means we have to say, Gerudo's absolutely unbroken sunshine is probably not climatically realistic. So with that, we are going to give Gerudo Desert an orange rating. Okay, but what about those highlands around Gerudo Desert? What biome are those supposed to be? Well, it snows up here. The vegetation changes and we see low-lying plants with scattered evergreen trees. Oh, and the wildlife changes too. So we classified it as a montane biome. But now, montane doesn't actually refer to a specific place on Earth. The biome is in fact defined by elevation. That means if you go high enough, everything will change in predictable ways. But what's remarkable about the montane biomes is this. Whether you are in the Himalayas or the Rockies, they can look surprisingly similar. Completely different continents, different latitudes, but the same elevation-driven rules. And what ties them all together? Snow. Depending on the exact location and elevation, mountains can get anywhere between 50 to 300 inches of snow per year. In game, we included Gerudo Highlands and Mount Lanayru as montane biomes. Both regions are at high elevation and have a lot of snow. But how much snow? Well, just like rain in other regions, it snowed every single day. The Gerudo Highlands averaged about 8.5 hours of snowfall per day. That's a massive amount of snow. But Mount Lanayru, it averaged 19 hours of snow per day. 19! At that point, the existence of the Sky Islands is just a rumor. You'd never be able to see them. Now here's where things get interesting. Most steady snowfall in the real world falls at roughly 1 inch per hour. And if we apply that rate to Mount Lanayru's average, well, that works out to be about 6,935 inches of snow per year. And that's 578 feet. Not inches, feet. I legit can't even comprehend that. I mean, I have been to cities before, but a typical skyscraper is about 1,000 feet tall, if not more. And I am just trying to imagine snowfall that is half of that. In Lanayru, you're not just shoveling snow to get out for work in the morning. You have to calculate the extra tectonic pressure just to survive. For comparison's sake, the snowiest places on Earth see roughly 600 to 700 inches annually. That's only 54 feet compared to the 578 feet we talked about. So Lanayru isn't just slightly above average here. The snowiest place on Earth gets a tenth of that. Lanayru's snow is as deep as a 42-story building, the same size as Tower 42 in London. Well, at least the Gerudo Highlands are a little bit better, but they still have more snow than anywhere on Earth. That means the montane biomes are also getting a purple rating. Aside from the impossibly deep snow, we found other surprises in the Gerudo Highlands. The weather changes incredibly fast. See, when we tracked the snow near the Highland Skyview Tower, we noticed something strange. Usually, those weather icons in the bottom right last 4 in-game hours. They normally switch over at midnight, 4 a.m., 8 a.m., noon, 4 p.m., and 8 p.m. But in this location, the icons kept switching around. Yeah, a sun would suddenly turn into snow, or it would stop snowing halfway through a snow icon. Normally, we only solve this in transitions between areas. For example, when you're at Link's house in Akla and you try to cross the road toward the big Sky Island rock, the weather forecast completely changes. The same thing happens when you fly across East Reservoir Lake. But here's the weird part. These transitions don't follow the named regions or biomes. Even though both sides of Reservoir Lake are temperate forest, they have different weather. And strangely, that actually makes sense. Surprisingly, in real life, rainstorms have sharp, discrete edges. I mean, you've probably seen them before off in the distance. It can be pouring in one spot, and half a mile away, it could be perfectly dry. We don't know exactly where storm boundaries lie in Hyrule, but the game clearly has distinct climate shifts built in. It's subtle, but it gives Hyrule a sense of dynamic weather within each region and biome. And that's why our randomized clustered approach is so critical for measuring rain in each biome, especially in the temperate forest. Because in this game, just like the Grasslands, the Temperate Forest is huge. Most of Lanayru, Akla, and parts of Eldin are all temperate deciduous forests. Deciduous trees are trees that lose their leaves annually, typically around autumn or winter, which means, in theory, there should be enough rain to support the big trees with leaves that fall every winter. But that amount of rain might differ between sections of the same forest. It's not as hot and or wet as tropical rainforests, but definitely wetter than the grasslands. In real life, temperate deciduous forests are modestly wet. In Hyrule, though, well, given that the tropical forests and grasslands already had enough rain to flood the planet, we weren't exactly optimistic. So, will they behave, or do I need to buy a boat? Well, across all these regions, it rained every single day for an average of 6 hours. And just like the tropical rainforest, about a quarter of that was heavy thunderstorms. That adds up to roughly 1,045 inches of rain per year. That's 87 feet of water, that's so much water. And actually, in reality, it's probably even more, because in the Lost Woods, it never rained at all. And that's really dragging down the average here. If you ignore the Lost Woods, the rest of the temperate forest regions would be even wetter. So basically, the deciduous forests in Hyrule are having a fun time playing dress up as tropical rainforests on steroids. Okay, I give up. It's time to buy a boat. This is getting another purple rating. Geez, I know Dr. MamaGoron likes purple, but this map is getting ridiculous. Maybe she's trolling us. Speaking of the Lost Woods, Eldin ended up having some of the weirdest weather patterns. See, the landscape of Death Mountain is modeled after a volcanic desert. But here's the thing. In real life, volcanoes aren't their own biome. Volcanoes usually get about the same amount of rain as the surrounding area. In fact, many volcanic islands are normally lush, green, and full of life. Volcanic deserts only look barren because the rain is acidic enough to keep most life from surviving. So maybe that's what's happening in Eldin? Well, we actually discussed the possibility of acid rain on Death Mountain in both of our water and air quality videos in this series. But it turns out that's not what's happening at all. Just like our research in Gerudo Desert, not a single drop of rain fell on Death Mountain. We checked back every 16 to 30 days for 8 months, and still nothing. In fact, the rest of Eldin was just as dry. So yeah, if we're judging by the precipitation alone, Death Mountain is basically a desert. So say goodbye to those nice hot springs, because they aren't lasting for very long. Gorons, we gotta move! We can't lose our bathwater! And that's another orange rating on the map. Man, orange and purple. That's like all there is. The last place we haven't visited yet is the beautiful and cold Hebra. It has snowy, pine-filled forests in the north and warm, swampy waters in the south. And that gives us boreal forests and wetlands. Boreal forests are the world's largest land-based biome. They exist below the Arctic Circle and cover huge swaths of Canada, Russia, Alaska, and Scandinavia. These regions have long, freezing winters, lots of snow, and coniferous trees. Coniferous trees are evergreens like pine, spruce, and cedar that never lose their leaves. Hence the name, evergreen. And that's exactly what we see in Hebra. Lots of snow, lots of pine trees, and besides the occasional moose or fox, not much else. But how much snow are we talking about exactly? Is Hebra normal? Well, on Earth, most boreal forests get between 15 and 40 inches of snow per year. Hebra? Well, it gets 4,309 inches, which is 365 feet. When we were there, it literally snowed every single day for 12 hours. 12 hours. I thought we already completed the snow quest here and saved Gerudo from the snowstorm. Was that all for nothing? This means all of Hebra must basically be a giant glacier. Is that why it feels like it's at higher elevation? Glaciers form when snow builds up over time. The weight of all that accumulated snow compresses the lower layers into ice, which freezes down to the bedrock. This only happens when accumulation exceeds ablation. Ablation? That's the snow and ice that gets removed by the wind, melting, or evaporation. The result? Well, it's firm layers of snow and ice, basically turning the ground into a permanent freezer. And with that much snow and below freezing temperatures all year, human civilization in Hebra probably wouldn't last long. In other words, don't plan on building a Hyrule IKEA up here. Purple again. So with that, our map is almost done. There is only one biome left to explore, the Wetlands. So are the Wetlands of Hyrule going to surprise us and be realistic? Or are we about to facepalm harder than Captain Picard after a night of heavy chess playing with Q and Data on the holodeck? So what are the Wetlands? Well, they're wet. These are areas with constant standing water, which means the soil is always saturated. And as the name implies, they also tend to get more rain than the surrounding grasslands. In Hyrule, we actually see a lot of small wetlands scattered around. For our study, the wetlands we included were limited to Lanayru and the southern part of Hebra. So, how much rain should we expect? Well, most temperate freshwater wetlands get around 70 to 80 inches per year, which is quite a bit more than the grasslands that have 10 to 30. And in Hyrule, well, it rains 907 inches annually, of course. Wait, what? Really? That's way more than any normal wetlands on Earth. But even more surprising is this is the first measurement that we've had under 1,000 inches of rain annually that we have seen all across Hyrule. And it's supposed to be for one of the wettest biomes. Let me just explain that a little bit more, how absurd this is. The wettest place in Zelda gets less rain than everywhere else. except for the deserts. But everywhere else, it gets more rain than the wetlands. I mean, it's so absurd that Nintendo couldn't even bother to get the relative amounts right. Wait. What in the Hyrule goddesses are we doing here? We can't say this entire map is purple, right? This can't be correct. Just hold on. I need to go make sure these numbers are right. Stay right there. Hey Doc, the whole map is purple. I don't think this data is right, like at all.
It's definitely right.
What do you mean? Okay, have you checked it?
Yeah, I even called that engineer I was working with and double checked all the maps.
Okay, well, what about the geologist?
Yeah, I talked to him too.
And the astrophysicist?
That's the next video.
Oh, okay. But you checked the math with him, right?
Yeah, I did.
Okay, because I'm about to come in here and, well, tell everybody that
it rained a lot. Like a lot.
wow, Okay. Well, the numbers are correct. In fact, we checked them with 3 different research consultants on this matter to check the math. Our old friend, who was a civil engineer up in Ohio who literally designed water filtration systems, an extraordinary geology professor here on Death Mountain with me who teaches full-time for this kind of stuff, and a literal doctor in physics to ensure our math is right. And you know, physicists are basically real-world wizards, right? And all of them, all 3 of them, agreed with our numbers. We wanted to be wrong. We absolutely wanted this to be wrong. You see, traditionally, before publishing a research paper, you have peers review your paper for publishing. And this is like that, except, well, way harsher, because your friends, my friends, aren't going to let me put something wrong up in front of millions of people who are angry just because I pronounced hot no a certain way. Okay then. Well, it's settled. I hate to report, but Hyrule is basically on the verge of an apocalyptic flood. And I don't think you can even blame the King of Hyrule for this one. Although maybe he has a boat we can borrow though. Let's look at what we actually found. We estimated snowfall at about 1 inch per hour and drizzling rain at 0.01 inches per hour. Normal rain at 0.3 inches per hour. And heavy rain at 1 inch per hour. And remember, these were all conservative estimates like we discussed before. They were the low end of the estimates. And here is how that data shook out. In blue, that's the average rainfall for Hyrule, which means in some places it rained even more than that. In red, that's the maximum recorded data for Earth, the max. For reference, the wettest place on Earth is, and I'm going to super butcher this name and I'm sorry, Mawsynram, India, which gets about 460 inches of rain per year. And the driest place in Hyrule, where it actually rains, gets more than double that. Oh, and snow? Well, the snowiest inhabited place on Earth is Tokaiu Onsen in Oyamori, Japan. They get over there almost 700 inches of snow per year, and there's nowhere else even close. But that still pales in comparison to the 5,447 inches recorded in-game. Hyrule isn't just wet or snowy. It's on an entirely different scale of absurdity. As you can imagine, these weather patterns would be catastrophic. Even the low rain regions are staring at the end of civilization. Gerudo Desert and Death Mountain? Well, with absolutely no precipitation, they shouldn't look like deserts. They should look like Mars. No oasis, no palm trees, no cacti clinging to survival. Although you might see a NASA rover or two rolling around here, though. In real-world deserts, there's still water deep underground. They are stored in aquifers from the last rainfall. We talked a lot about aquifers in our water video. The entire ecosystem survives on rain that fell months or even years ago. But if it never rains, well, then the aquifers drain out. The plants lose access to water, and the animals disappear, not being able to get that sweet bite of food. Maybe you could argue that Gerudo Desert is being fed by the groundwater from the Highlands, but those Highlands are never warm enough for any meaningful snowmelt. No meltwater, no recharge, no gushing aquifers. Suddenly got really thirsty. Talk of water. For you guys, it seems like I'm just talking for like an hour, but I've been doing this for already 2 hours, so it takes a long time to record these. And what about those highlands buried in snow? If it never warms up, the snow never melts. At least not much, or rather not enough, which means 365 feet of snow builds up every year. The snow compacts, compact snow eventually becomes rock-solid glacial ice. Oh, and that glacial ice, that whole mass starts to move. Because all glaciers move. But when you're dealing with hundreds of feet of accumulation every year, the pressure becomes enormous, and gravity does the rest. Also, glaciers aren't gentle. Just ask the Titanic. They grind, they scrape, and they shear off mountaintops. They'll even bulldoze entire forests. I mean, have you ever flown over the central United States and wondered why it's so flat? Well, it was carved and leveled by ice sheets up to 2 miles thick. They smoothed ancient mountain ranges. They filled valleys with sediment and literally rewrote the topography of the land. If Hebra is truly receiving that much snow, it wouldn't be just snowy. It would be growing a terrifying ice sheet. And over time, that ice would move. It has to. And when it does, Hyrule won't just have a weather problem anymore. It'll have a geological one. Over time, all of Hyrule will be crushed by the weight of these glaciers. Hope you made friends with the hero of time. So the cold regions freeze rock solid. The deserts, they collapse from dehydration. And the mountains grind themselves flat under the migrating ice, completely wrecking Hyrule in the most dramatic way possible. Okay, so we talked about places that get no rain, and we talked about places that get way too much snow. But what about the rainy regions? What happens when it rains every single day? Well, once the heavy rain sets in, the real problem begins: erosion. Fast-moving water starts carrying soil downhill, grain by grain, layer by layer, right downhill, until fertile ground becomes exposed rock. Now, plants can slow it down for a while. Their roots grip the soil, holding it together like all that duct tape you used. The roots aren't engineered for perpetual downpours, though. There's a limit to how much force they can resist, and eventually the water wins. The soil goes first, then the plants, and then so does everything depending on both. So if the rain keeps up long enough, it doesn't make the land lush. It washes it away and makes it barren. But what about places that aren't steep? Well, erosion carries soil downhill. Runoff moves water to lower ground. But if you're already at the bottom, well, that's not a great place to be. You get flooding. Now, in the real world, flash floods usually come from extreme rainfall events or failed infrastructure like dams. When rainwater falls faster than the earth can absorb it, the water starts to pool. But that's not what's happening in Hyrule. Hyrule isn't having a sudden natural disaster. It's having a nice, predictable, unrelenting rain. Hour after hour, day after day, month after month. But when the ground is already saturated, even moderate rainfall has nowhere to go. It doesn't soak in, and it doesn't drain away fast enough. It just rises. Slowly at first, though, and then all at once. So what will Hyrule look like soon? Well, that depends on something. A very interesting question. How big is Hyrule? How steep are the slopes? And what kind of rock and soil are we dealing with here? Because flooding isn't just about rain, it's about where the rain goes, how much the land can absorb, and how much it can't. So to figure out just how cataclysmic things are about to get, we did what any reasonable Gorons would do. We measured it and broke it down. In the heart of Hyrule lies a lowland, from Lake Hylia all the way up to Hyrule Castle, and from the edge of the Gerudo Highlands across to Lanayru Wetlands. This entire region forms a basin, and that means it collects water. Every drop of rain from higher elevation flows downhill. And if Hyrule has a place that's quietly waited to become an inland sea? Well, it's this area. It's Hyrule Field. To start our flood investigation, we need to understand two things: percolation and runoff. Percolation is what happens when water soaks down the soil, filling up the underground aquifers. But not all soil behaves the same way. Sandy soil, for instance, has large spaces between grains, so water drains through it quickly. Healthy soil full of decomposing leaves called loam is generally more balanced. It absorbs water at a moderate rate. But clay is dense. The spaces between particles are incredibly tiny, and water moves through it slowly, which means in clay-heavy areas, most of the rain won't soak in. It stays on the surface and moves downhill. And that's assuming you have soil at all. If the surface is mostly rock, well, that's about as impermeable as it gets. And when you look around Hyrule, sure, you see grass and trees, which suggests loam, but it's clearly not very deep, because it feels like every 5 steps there's another exposed slab of bedrock. And the slopes? Sheer cliffs. So we know that all that rain falling in the lowlands and on top of the surrounding cliffs eventually drains into the central basin. But how much water is that exactly? See, it turns out that an inch of rain falling doesn't equal an inch on the ground. I know that sounds super confusing, but bear with me here. Here's the important part. When we say an inch of rain, that's a height measurement and not a volume. Volume depends on area. It's length times width times height. So 1 inch of rain doesn't mean much until you know how big the surface is. So if we want to know how much water is building up in Hyrule, we need to answer one critical question. How big is Hyrule? Or more specifically, how big is that central basin? Now, that's a tricky question. It could literally be an entire video on its own. And that's because the basin isn't a nice, neat rectangle. It's irregular, messy, a lot like MamaGoron's open tabs after finishing her research. Her computer, man, let me tell you, it sounds like a NASCAR engine by the time she is done researching. Coming up on turn 2. So we did what any reasonable adults with access to a video game would do. We used math, or more specifically, calculus. Math in Zelda is pretty hard to execute in game given that there are no real conventional ways to measure distances. In calculus, if you want to find the area under an irregular curve, you break it into a bunch of tiny rectangles and add them all together. It's called integration, but really it's just organized measuring. So that's exactly what we did. We ran around Hyrule cataloging the X and Y coordinates of key points around the basin. Then we divided the area into rectangles, triangles, and circles. And we calculated the area of each of those shapes and added them together. And boom, just like that, we had an estimate for how big the basin really is. Turns out Link isn't the only one grinding side quests now. And the answer to our little question is 6,839,721 units squared. Wait, units? What the heck is a unit? Oh, yeah, duh. Zelda isn't real. I mean, at least I think it isn't. So the X and Y coordinates don't come with meters or feet or anything useful for measuring. And to make it worse, no one on the internet seems to agree on how big an in-game unit actually is. Some said 1 meter, and others came up with an equation that makes Link about 4 feet tall, which, hey, at that height his jump stab is probably pretty on point. But none of these calculations are solid enough for us to accept. So how do we resolve this? Well, if the game isn't going to give us any units for measuring, easy. We make our own, using the in-game environment and objects that would be roughly what we expect them to be in our world. So we headed to Lookout Landing for a little dimensional sleuthing. Now, no one can say for sure what the rules are in Hyrule, but in the real world, some things are surprisingly consistent. Most stair risers are about 7 inches tall. One floor of a building is roughly 3 meters, and exterior doors are usually a little over 2 meters high. So we started measuring staircases, buildings, doors, anything that should be standard and didn't have an annoying bar right above the door that Link hits his head on every single time. We compared those real-world dimensions to the in-game Z coordinates, converted everything, averaged it all together, and landed on this. One in-game unit is roughly 0.61 meters. From there, it was just a little math magic. So the entire central basin of Hyrule comes out to be about 2,545,060 square meters, or about 628 acres, which is just shy of a square mile, and roughly about the size of Central Park in New York, which is way smaller than we initially hypothesized, but incredibly convenient. I love it when my impending cataclysms fit nicely into my mathematical equations, and that actually helps with our rain math. Now we know 2 things. 1, the rate of rainfall in Central Hyrule, and 2, the size of Central Hyrule's basin. So, what's left? Well, in the real world, meteorologists and civil engineers use something called the rational method to figure out how much rain will flow into a drainage area. Personally, I am thinking of calling all my ideas rational from now on. That way, no one can argue with me. This video is rational. The rational method is used to estimate the peak water flow from rainfall. And the rational method has been around for over 150 years for calculating flow. So it's a pretty seasoned method. Okay, but what is the rational method? Well, the equation is simple. Q equals CIA. No, not that kind of CIA. We're not stealing secrets or trying to topple governments here. This CIA is runoff coefficient, rainfall, and the area in acres. Using the rainfall, we measured the area of the basin, factoring in steep, rocky cliffs, and running these numbers past our friend, the aforementioned board-certified environmental engineer in Ohio, we calculated a peak runoff rate of 175.8 cubic feet per second. And if you dumped that into a basin the size of Central Park, well, the apocalypse isn't on the horizon. It's already here. In just 3 measly days, the entirety of Central Hyrule would be a foot deep in water. In 1 month, 10 feet of standing water. In just over 3 months, 50 feet. That's a 5-story building underwater. At this point, with this rate of rainfall, Link may want to consider changing his name to Noah. But you might be asking, MamaGoron, wouldn't all that water soak into the ground and fill up the huge underground aquifer under Hyrule Fields? And you'd be right. All of these calculations assumed the aquifer was already full and no water could soak in. But is that even possible? Well, let's do the math. Aquifers can be enormous and incredibly variable in size. But for now, based on what we see in game, we think this might be a limestone aquifer. See, limestone aquifers vary in depth from 8 feet deep to almost 2,000, but 500 feet deep is a fairly common size. So if we assume the aquifer is 500 feet deep and has the area of our central basin, we know the volume is about 104.2 billion gallons. But remember, aquifers are mostly rock and soil, and limestone? Well, about 80% of the volume is rock and the rest is space for the water. That leaves 20.8 billion gallons left for the water. And with our flow rate from the rain? Well, that aquifer would fill in about half a year. So our assumption that the aquifer was full is actually reasonable if the aquifer is confined to that space. And when the aquifer fills, the soil becomes fully saturated. And that's when every single microscopic space in the soil fills with water. And we know what happens next. So why isn't Hyrule back to its Wind Waker era? And how is everything so dry? Seriously, go check any well in Hyrule. Chances are it's bone dry or close to it, which means the aquifers feeding them must be dry too. So where could all that water possibly be going? Well, there are a few options. Maybe Hyrule's aquifers drain right into the ocean. We know this happens in the real world. Take the Floridian Aquifer in the southern US, for example. This enormous underground reservoir feeds both the Gulf and the Atlantic Ocean. And the key thing, if the aquifer is flowing like this, the wells don't run dry. Because when fresh water disappears, salt water sneaks in, with a process called intrusion. Since Hyrule's wells are dry but not full of salt water, this clearly can't be the solution to our problem. So where is all the water in Hyrule going? Well, maybe the depths. Oh yeah, the depths. So yeah, the depths are enormous. Even though they were only recently discovered in Tears of the Kingdom, they've probably been down there the whole time. And there could be thousands of feet of aquifer actually lurking beneath them as well. And critically, unlike a normal aquifer, the depths aren't 80% stone. They extend down to negative 2,500 on the z-axis, which is almost a mile beneath Hyrule Field. Even if the depths exist only under the central basin, and you consider the space from the floor to the ceiling, that's over 1 trillion gallons of available volume. And that's not even accounting for the depths extending under the entire map and the aquifer space above and below. This is enough room to store water for thousands and thousands of years. So could that be what's happening? Could the depths be saving Hyrule from a rainfall cataclysm? Or is there something we missed and we should be preparing for the Wind Waker 2? Let us know down in the comments below. And while you're down there, don't forget to like, subscribe, hype the video, check out our Discord and Patreon, and stay dry out there. My name is MamaGoron. Thank you so much for watching, and I will see you on the next one. Bye.
Where have you been? Been searching all along. Confusing twilight on and on. Without a clue, without a sign, without grasping light. The real question to be asked: where have I been? I'm a shapeshifter at Post Masquerade, hiding both face and mind, all free for you to draw.
Okay, wait a minute. So, could the depths have been flooded at some point? Did we accidentally solve the Zelda timeline and figure out where Breath of the Wild and Tears of the Kingdom are? I definitely did not have that on my docket for today. And it's a good thing the king is not around anymore. He had just quickened this whole flood thing going on. I mean, at least the last time he touched the Triforce, he made the water recede. Ooh. Maybe we can just wish on the Triforce to make all of this flooding and weather nonsense go away. But like, does the Triforce even work like that? I mean, could a normal person like me even touch the Triforce? I mean, that thing gives off so much light, it has to be hot or at least radioactive. Wait. Oh, snap. Is the Triforce radioactive? Because if it is, well, you probably know about Chernobyl.
I'm a shapeshifter. What else should I be? Please don't take off my mask, revealing dark.